Okay, great. Thanks so much. I'll start with the key takeaways that I want you to have from this presentation. One is that as you go into cloud native, testing changes, and that's what I'm going to talk about. And that's something you need to take into account when you're planning and when you're building infrastructure and all of those things. And the other key takeaway is that you should be familiar with the Test Cube product and logo, and it's going to be on every slide. So if you're don't remember it after this, you haven't been paying attention. I'm CTO from Test Cube. I'm based in Stockholm. Great to be visiting here in Vienna. My parents live here, so that's a great excuse for me to come here also. Okay, so a little bit about how cloud native is changing testing. And I know maybe testing is not top of mind for everyone all the time, but it is something, quality is something that everyone agrees is important. Obviously, moving to microservices, to containers, to Kubernetes changes how we test those containers and how we test microservices, and how do we test in Kubernetes, and what does Kubernetes mean for testing when it comes to everything from infrastructure to performance to security to anything that can be traced to quality of the applications we're deploying. Applications are much more distributed under Kubernetes. So what does that mean for testing? How do you test for resilience across clusters maybe? How do you test for anything related to two components not being right next to each other where things can always go wrong? We're adopting dynamic and ephemeral infrastructure, and infrastructure is code. So if you're doing GitOps or using Terraform or anything like that, how does that play into testing? How do you test that infrastructure? How do you leverage that infrastructure for testing? I'm sure it's something that many of you can relate to. We're moving to more asynchronous pipelines. So instead of having a synchronous delivery pipeline with something like Jenkins, you're moving to asynchronous, where you're using GitHub Actions or GitLab, and you're using Argo CD or Flux, and you're using Argo rollouts or Cargo. And how do you kind of then integrate testing into all of those steps in a way that's still kind of coherent? And finally, you're probably using AI to generate code and maybe configurations, and that drives velocity. And how do you make sure that you have testing in place to kind of weigh up for all this stuff that you're generating, and that you don't always have the time to review manually, and you're putting more and more trust into the models that you're using. So you need more testing, and you need to think about it. And if you look at the continuous delivery pipeline, testing is really all over the place, right? It's everywhere from... Is there a pointer? No. Does this have a pointer? Top. I don't know. Sorry. Here we go. I'll just allude to the slide. As you can see, testing happens everywhere. It's part of the planning phase. You have to plan how you're going to test. It's part of the coding phase. If you're doing like shift left and you're doing testing early, it's when you're building locally, you're running unit tests, maybe some component tests. When you're testing in CI/CD, maybe you're provisioning ephemeral environments for testing. When you're releasing, you might want to test those artifacts that have been released. When you're deploying, you might want to run tests as part of your progressive delivery or part of your GitOps deployment. In operations, you might want to be testing continuously to validate that stuff is working, and you might actually be testing in production, which a lot of companies do. So testing is really all everywhere, and that's what we're kind of talking. The term continuous testing is something that's kind of being more adopted more and more. You see also the shift right is also part of that. So doing testing both earlier, shift left, but also later, and collecting quality metrics in pre-production and production environments, which is shift right. And this then proliferates, right? So you have multiple pipelines. We heard about breaking down monoliths into microservices. So that one thing that used to be one monolith is now 50 microservices, and each of those has its own kind of delivery pipeline, and it's running in different environments, and you're using multiple testing tools. You're using the old ones like JMeter and Selenium, and you're using the new ones like Playwright and K6, and all of that needs to be kind of coordinated, and then you might be triggering those tests in a bunch of different ways. So it can be kind of overwhelming, at least if you're in a larger organization or have a larger infrastructure. So what do we mean by continuous testing? So you're familiar with continuous integration and continuous deployment, of course. What we mean here is automated validation at every stage of the software development lifecycle. You want to have tests being triggered automatically by events or by your orchestration tools or build tools, CI tools, CD tools. This could be both synchronous or asynchronous. You need observability in continuous testing. I'll get back to that a little bit. And then you have the concept of quality gates, which is becoming increasingly important if you're doing GitOps and progressive delivery. And I'm guessing many of you are in the ops space, and many can maybe think, what is testing to me? Isn't testing something that developers and testers do? And you're totally right. Testers and developers do a lot of testing. They define tests, they write tests, they plan which tests to run when, both automated and manual tests. They troubleshoot failed tests, and they look at logs, and they misspell, as I did, they result reporting and analysis. But ops and DevOps people also have a lot. They have to integrate the automated tests into their CI/CD pipelines, which means not just executing tests, but it also means collecting logs and artifacts and metrics that the developers in QA need to troubleshoot their tests. You need to provision testing environments, which you might want to do to be able to test, do more end-to-end tests as part of your CI/CD delivery. You need to provide access for all those developers and QA people to those tools where you're collecting all these things. Often ops people are responsible for non-functional testing of the requirements. So performance testing, security testing, compliance testing, infrastructure testing, chaos testing, something that usually falls on DevOps and ops people, not QA and dev. Of course, there's not a fixed line. And that means those people are defining, writing the tests, planning the tests, when to run them, troubleshooting the tests, everything. So there's a lot of testing that falls on the ops teams as well. And finally, platform engineering are the teams that maybe try to provide some kind of testing framework or scaffold or infra tooling that everyone can use. So you have a consistency on how you run your tests. And they might want to integrate all of that into your IDP if you're using Backstage, for example. So testing is definitely something that spreads across the entire team and everyone in it. Okay, so what are some challenges related to testing then? One is just consistency. How do you make sure that you get the same results for a test when you're running it locally, when you're running it in your CI/CD, when you're running it as a part of your progressive delivery? Because as you can all imagine, you'd like the same test to always have the same result and not different results depending on where you run it. This can also be across geographic clusters. Let's say you're deploying your applications in different environments. You want to make sure that you're getting consistency there. It could be across cloud providers if you're running the same tests in different same applications and tests in different cloud providers. And once again, depending on if you're using multiple CI/CD tools or deploying in different ways, you want to make sure that you're getting consistent results there and that you can scale your tests accordingly. Observability is the next one, collecting logs, artifacts, and results, and those can be spread out over multiple tools. So let's say you're running an end-to-end test against a microservices application. It touches 20 microservices. The tests fail. You're going to have to maybe look at the logs from each of those to figure out where did the failure happen. How do you collect all of those logs? How do you make them easily accessible? Give them to AI for some analysis, etc. How do you correlate events? Let's say you update Istio and tests start failing. How do you make that correlation? How do you help people understand that the reason the tests are failing now is not in the application, but it is because of an infrastructure change, or not? But how do you make sure that all of the things happening in your application infrastructure are visible and correlated to help you troubleshoot? And then how do you define and track all of the quality metrics? Your QA manager wants to know how many bugs do we have per component, per team? Are we trending in this way or that way? Are we kind of achieving the quality metrics that have been set up for us? Release promotion, next one, quality gates. How do you define a quality gate? How do you find when is what ready to release? If you're releasing microservices continuously, maybe you're never really releasing an application as a whole. You're just incrementally updating different components. What are the quality gates to help you do that when you know you're ready to release? And surprisingly, many have not like 100% pass rate. They're fine with 90% of their tests passing as long as a certain set of tests doesn't fail. So there's always some kind of lax flexibility there. And all of this I mentioned here doesn't just cover functionality. It goes also to performance, security, compliance, if you're in a compliant industry. So it's just a lot to take in. Another big, which I mentioned earlier, is moving from sync to async delivery pipelines, which I'm sure many of you have faced as you adopt GitOps. So instead of having just one tool that orchestrates your entire delivery chain, you have multiple tools, and then you have events driving the triggering of the next step. So if you're using the bottom here, GitLab, GitHub, or something else to build an artifact, when that artifact gets published, that triggers off Flux or Argo to do a GitOps sync, which then itself maybe triggers a delivery with Argo rollouts or Cargo or whatever tool you might be using. And how do you then into these inject testing to make sure that whatever goes through each step is supposed to does go through that step in the way you want it to. And finally, infrastructure testing. This is actually pretty common. As you dynamically provision infrastructure, you want to make sure that it has all the access to the resources it needs. So let's say you're provisioning infrastructure that's going to do AI workloads. You want to make sure that you have GPUs available. You might want to make sure that you have network topologies in place so that whatever you deploy in that infrastructure can talk to whatever else it might need to talk to. You want to make sure that you have your policies and RBAC in place. And finally, if you have any other dependencies that you're installing Prometheus or ingress controllers, etc., before you put your actual workloads in that infrastructure, how do you test for that? And there are a bunch of tools out there to help you do infrastructure testing, of course. Question is then, how do you orchestrate all those tests to make sure that they run, and then it all kind of comes together. So this kind of all adds up to a lot of complexity. Just can look at the things. You get fragmented testing environments, you have lack of consistency, you have CI/CD bottlenecks, you might have lack of tester observability, scaling challenges, and test sprawl, meaning that you have tests running a little bit everywhere and you don't really have good insights into how you're doing your testing today. So wouldn't it be nice then if you could launch any test, anytime, in any environment, if your testing was making and not breaking your CI/CD pipelines, if your dev, QA, and DevOps were all using one platform for testing, for test execution, if you could orchestrate tests leveraging your existing infrastructure instead of having to go to a cloud provider for running tests themselves. And finally, if you had a unified view of all the testing activities that were happening across all those pipelines that I kind of alluded to earlier. But how do you get there? And what many people do today, and I'm guessing many here as well, is you leverage your CI/CD tool. You have GitHub Actions and you have Jenkins, and you do a lot of scripting and try to cobble together the plugins you have there. And that's a great initial approach because it keeps everything into one place. You have one ecosystem that you're very familiar with. But it does result in high maintenance. You're going to have a lot of scripts to manage. You have a lot of dependencies. It doesn't usually scale across multiple CI/CD. So if you're using, like I said, GitHub Actions, Argo, Flux, etc., you're going to have to do scripting multiple times in different ways to achieve the same thing. And CI/CD tools generally aren't focused on testing. They're more generally job tools or job execution tools. So they lack some of the granularity that is required for test reporting and for aggregating results that would be needed for test-related jobs like troubleshooting. The next things that you could do, and you could do that on top of course, leveraging CI/CD, is integrating point tools. There's the pros here is that you have the right tool for the job, and there's a bunch of tools out there for reporting. You can look at Allure. For other steps, you can use other tools to really kind of maybe focus on the steps that are important to you and to your organization or the way you deliver software. The downside here is that it's going to be, once again, more scripting, and you're going to have a more fragmented infrastructure. And it could also have security concerns. How do you kind of propagate, federate logins and users across all the systems that you've integrated? And finally, you can have a dedicated platform for continuous testing, which, as the pro, that you have everything kind of in one place. You might have a single pane of glass that is really built for solving some of the problems that I've been alluding to. But the cons is that a platform like this will will lack some of the depth that you could get out of a point tool. So let's say you're using Grafana for reporting on test results. That's ultimately going to be much more granular and powerful maybe than a continuous testing platform, which is more focused on going wide. So there's definitely pros and cons for all of these approaches. And usually, like I said, many start with the first one, and that's where they are when they start looking at something like Test Cube, and they wonder how can we kind of evolve this into a more coherent way of managing testing in our environment. Okay. hello Test Cube. So if you haven't guessed it, this is where I'm going. So I'm going to talk a little bit about Test Cube. It's a project that I work for and that tries to solve some of these problems that I've been alluding to. Test Cube is what we like to call a continuous testing platform. So it has a test workflow catalog, a catalog of all the tests that are running in your infrastructure. It has an execution engine built on top of Kubernetes for running your tests. It does all of the test observability stuff in a way that's really helpful for people who need to work with test results, so dev and QA for troubleshooting and reporting. And it has an analytics portal on top of that. And it has an MCP server, which is great, of course. So how is it different? Well, so Test Cube decouples your test execution from CI/CD, which is maybe the most important thing. So instead of having your CI/CD tool run your tests, Test Cube runs your tests leveraging Kubernetes, and then you trigger those tests from your CI/CD tool. And since we have many of our customers having multiple CI/CD tools, it's much easier for them to start reusing those tests in multiple scenarios instead of having to script them separately for each tool. They also get them the consistency of running tests from however they're triggered. It's GitOps ready, and I'll get back to that in a little while. It provides that centralized test observability that I've been talking about. It's Kubernetes-native, meaning that it leverages CRDs for defining tests. It hooks into Kubernetes events, and it uses Kubernetes low-level constructs for running tests at scale. It's tool agnostic, so maybe important to point out, it's not a testing tool, so it'll take any test you have today. So if you have K6 tests or Playwright tests or Selenium tests or Postman tests or whatever, anything that can be Dockerized, Test Cube can take those tests and orchestrate those inside your Kubernetes infrastructure. And it's AI enabled. Yay. The kind of core secret sauce of Test Cube is what we call test workflows. So we've kind of built our own workflow engine, which some people would question because there are already a lot of workflow engines out there. And the reason we've done that is we felt that none of the workflow engines out there, if you look at GitHub Actions or Argo Workflows or other engines, they're more generic workflow engines and not really good at things that are important for testing, meaning sharding, parallelization, composition and reuse, multi-cluster orchestration, and services and templates, meaning parallelization. Let's say you want to spin up a K6 load test across 20 nodes, super easy to do with this syntax. Multi-cluster orchestration, let's say you want to run a sharded Playwright tests across multiple clusters, super easy to do with this syntax. So this syntax has really been built for test execution. It's not great at building or data workloads like Argo Workflows, for example, but it's really, really good at testing. And these are managed as CRDs in your clusters. And when they're executed, they're translated to jobs and pods in Kubernetes. So at the bottom, it's still native Kubernetes constructs that are executing, and they're also highly customizable. So this goes way beyond having like a GitHub action runner in your Kubernetes infrastructure, which is very self-contained. If you're running a parallelized test in a GitHub action runner, it's going to run all of those in one pod instead of us spinning out multiple pods for each node in a parallelized test. High-level architecture of Test Cube. There's an agent, which is the bottom part here. This is an open source component. You can run this in your cluster, and the agent contains that whole workflow engine that I talked about earlier. So you can leverage many of those features and most of those features in open source. And the agent runs those tests in your inside your clusters against your applications. And then if you have multiple agents, you can add a control plane on top of that, which is our commercial offering. I'm not going to talk more about that, but it's a kind of a management layer. It's a pretty common model, I would say. Speaking of GitOps, common question is, how does Test Cube fit into that? So, which I'm guessing many of you are doing, or at least looking at. So pre-sync in Flux and Argo, if you want to validate infrastructure or dependencies before you run your sync, in Flux, there is a specific pattern that allows you to inject jobs before the sync happens. Argo has a little bit more smoother approach here. They have what they call pre-sync hooks, and you can use that to run any tests using Test Cube. In sync, meaning while the components are being deployed, Test Cube can kind of hook into your Kubernetes infrastructure and run tests whenever things are updated. So this can be a super powerful way just to validate individual components, regardless if they're updated with Argo or Flux or just by kubectl apply. And finally, post-sync, which is the most common. is you can in Flux, there's an inverse version of this the job pattern with customize to run jobs after a sync, and Argo has post-sync hooks, which makes it really easy to run tests after. The hard part here is rolling back. If your tests fail, that's not super easy in either of those tools. It's something you have to kind of cobble together depending on how you set up your infrastructure. Okay, so why would you use something like Test Cube? There are other platforms out there. It's really about empowering engineering teams to run any test whenever they need to, not only in CI/CD, but as part of GitOps, manually, as part of, on a cron schedule every 4 hours, pretty common approach. It's cost efficient in our sense that we use your existing Kubernetes infrastructure to run your tests instead of using a cloud test execution provider. It gives you governance of all your testing in one place, and of course of all testing results as well. And it's very compatible with, as I've mentioned before, both Kubernetes constructs, GitOps, and platform engineering approaches, so you can easily integrate it into kind of the infrastructure that you're building. Do we have time for a short demo? How much time do we have? Okay. I'll show you. I asked before, has anyone heard of Test Cube? Hands in the air. Okay, that's awesome. Thank you. Let me see here. Okay, so this is the workflow catalog that we have. I'm looking at the control plane. This is a demo environment. It's called Paris because we created this for KubeCon Paris a couple of whiles ago. You can see different workflows, as I mentioned before, for different testing tools. So these are for Playwright, for PyTest, for Cypress, for, I don't know, I'm sure there's curl, K6, etc. You can look at this K6 test here to see how the network is playing with this today. I guess not.
That's the Wi-Fi everyone.
Yeah, I'm going to blame it on the network. Let's see if this comes up.
Stop correcting GitOps ISOs.
That was annoying. Okay, let's jump back there in a little while. And I actually had only one more slide, which is this one. So as I was so impressed by your attire, I had to add this picture. This is me and my 2 sons. We ran a 10K run in Stockholm in the middle of the night with lederhosen. And continuous testing of lederhosen. It took about an hour. It was actually not that uncomfortable. So kudos to Austrian streetwear. And we had everything here is authentic. I think we had, thank you. My sons don't know I'm using this photo, so I don't think they would approve. We had real Stutzen, which is these kind of green knitted socks. And yeah, I think the only thing that wasn't true was the shoes, as you said, because I don't think that would have worked out. Okay, thank you so much. I'm sorry the demo didn't work. Happy to show if anyone's interested afterwards. I'm here. I'll be here for a little while more, and you can use any of these ways to get in touch.
Cool. Thank you so much. Applause again.